Hi everybody, welcome to STEM with Mrs. Stella. So since I can't be here with you in person, I thought I would do a super cool reaction. This one is called the carbon snake, and I think we'll see right away why it's called that one. A few safety precautions I'm taking here. Notice I'm wearing my goggles. It's raining now, by the way. I have a pitcher of water right here. I might not need it because of the rain. This is in case the fire gets too high, I could put it out. And also, always be supervised if you're doing an experiment at home. I don't suggest doing this one at home because it involves fire. So that's why I'm doing it here for you today. It's a really cool reaction. So it's actually a combination of 3 reactions that are all involving heat. So here I have a bunch of sand. And in the sand, I'm gonna make like a little well right here, a little hole. And to this, I'm adding, this is a combination of baking soda, which is sodium bicarbonate, and sugar. And I'd say it's about 4 times the sugar to sodium bicarbonate, okay? And I'm going to wet all the sand around it with rubbing alcohol. This is the accelerant for the fire. Again, don't do this at home. Okay. Now I'm going to light it on fire, and you will be amazed by the cool reaction that happens, and I'll explain it as we go along. Okay, it has begun. Okay, so there are 3 different reactions going on here. So you see the fire happening here. The sugar, which was 4 grams, is burning. And in the presence of oxygen, it releases carbon dioxide gas. I'm going to move over here.
The rubbing alcohol movement.
Okay, and the next thing is there's water vapor, which is going to push all the sugar and ash upwards, okay? Then there's extra sugar, which burns, but there's not enough oxygen, and it pushes the sugar and baking soda up like it did before, but now it goes through thermal decomposition, and that's what's giving it this cool black color, and it'll also give it the snake shape. It's pretty windy and rainy out, so bear with me here. And then finally, the baking soda decomposes and becomes a solid, which is sodium carbonate, not sodium bicarbonate. Okay, so we're seeing the snake form. My husband is filming, and if you can kind of get in a little bit closer over here, you can actually see a snake kind of forming out of it. If you notice, I have my pitcher of water ready to go. This is not something to try indoors. So if you do this experiment, it takes about 15 to 20 minutes, and it actually rises out like a big giant snake. In the meantime, from my end, it kind of smells a little bit like what happens when you make s'mores, when you smell that burning sugar. Anyways, you can see it's becoming like this funky shaped ash that burns out of here. Okay, we're lucky today. We're getting 2 snakes out of it. Usually you only get 1. Today we're getting 2 carbon snakes, or sugar snakes it's commonly called. And the rain is not ruining this for us. It's only sprinkling. So that fire is still going. But you could see why I took the proper safety precautions, why I have water close by, and also why I'm wearing goggles, and also why I'm doing this outdoors. Okay, if you take a look of the shape that's happening right here, that's from the excess sugar, like I said before, burning off, but without as much oxygen. So it's going through something called thermal decomposition, where the heat is breaking it down, forming this solid carbon that we see. And It's really cool at many different angles right here. I'm watching it slowly grow out of the sand. The sand doesn't react in any way. The sand is just a good base for it, and it's fire safe, and it also soaks up the alcohol, which is the accelerator that I used. Fire's kind of dying down. I think you guys could see why I've never done this one in class before. It actually smells pretty good, burning sugar. You can see there's a tiny little snake still forming out of the end over there. And I will try to do weekly experiments for my students. This is also a great time, since we're home, to work on your science fair projects with one of your students. Okay, it's still burning. Okay, I think that's about how far it's gonna go. But if you can see, it's an awesome carbon snake. I'll show it to you from different angles. I like this angle the best. You can see how it came out as a snake. And it's actually really ash. I wouldn't touch it right now because it's too hot. Right now I'm gonna take, just to make sure there's no fire left in it, I'll take my water, see how hot it is. See how hot this mixture is, just to make sure that it's fully safe to be out here. And that's our experiment this week, everybody. Stay tuned. I'll be back next week with the traffic light oscillating reaction.